Okay, now for the last page, page 3 of the 3.7 notes. Here we're going to talk about solving problems involving joint variation for starters. So if you are given the words y varies jointly as m and the square of n and inversely as p, we would write that as an equation. Y varies jointly as m and the square of n and inversely as p. So there's your variation equation. Now let's substitute in what we know. We know that when y is 15, k is that constant of variation that we don't know, and when m is 2, n is 1, and that's to be squared, p is 6. So if I substitute in all the information given, I can solve for my constant of variation. 2 times 1 is 2 over 6. I can simplify that as 1 over 3, giving me 15 equals k over 3. Then I'm going to multiply both sides by 3, and I get my constant of variation, k equals 45. I'm going to substitute that back into my variation equation. K is 45 times m times n squared all over p. I should erase that a little bit. Now, we have been given additional information, and we are being asked to solve for y. So we are finding y when m is 3 and n is 4 and p is 10. So I'm just simplifying the right-hand side. 45 times 3 times 16 over 10. And if I multiply everything in the numerator, oh, that's 10, and divide by 10, I'm going to get y equals 216, and we're done. So, how can you determine or identify direct or inverse variation? Well, for starters, you have to know the direct variation general form of the equation, the inverse variation general form of the equation. From that, you can solve for k. So if I were to solve for k in this equation, I would divide both sides by x, and I'd get k equals y over x. So that's how you identify the constant of variation for the direct variation problems. If I'm looking at my inverse variation general equation, I would be multiplying both sides by x. So then k would equal x times y. That is how you identify the constant of variation. So if you're looking at example 7, you are being asked to determine whether each data set, so you have two tables of values, and you're trying to determine if those tables of values, that data represents direct or inverse variation, or perhaps neither. So, keeping in mind k, we can solve for k for each of these sets of points to determine the variation. Or you can just kind of look at the pattern for x and y, and at the very beginning we talked about if they both increase or if they both decrease, it's direct variation, and as x increases, y decreases, or as x decreases, y increases, we have inverse variation. So let's go ahead and just kind of look at it. If I look at my x values in my first table, I see that my x values are increasing. If I look at my y values in my first table, I see that my y values are decreasing. So you can see that perhaps this is inverse variation. However, we have to double check to make sure we have a constant k. So we actually have to find k. So we can look at, we think it's inverse. So if it's inverse variation, we need to see if this is true for all x and y pairs. Is that k constant? So for inverse variation, k equals xy. So let's go ahead and multiply x times y for each of those sets. So this would be 6 times 5, 6.5 times 8, which is 52. Now let's look at the next pair of xy. That's 13 times 4, which is also 52. But we can't assume that the last set of xy values also gives us 52. But if we do the multiplication, we see that we have a constant of variation for this problem as 52. So if I were to write the inverse variation equation that corresponds to this, it would be y equals 52 over x. So I have found my inverse variation function. So this one, in fact, is inverse. But don't automatically assume because both the x and y are going in the same or different directions that it's direct or inverse. We actually have to check for the constant of variation. But that gives us a clue as to which one we want to check first. So let's look at the next one. In this table, we investigate our x values and we see they are increasing. If we investigate our y values, we see that they are also increasing. So we think perhaps it's direct variation, but we have to confirm that there is a constant of variation k. Now the relationship for k for direct variation is y over x. Now don't get confused by the fact that you say direct and you see a ratio over here on the right-hand side. This is for k. This is not the direct variation function where y is isolated on the left-hand side. But let's go ahead and investigate our k's. So if I take the ratio of y over x, what do I get? 6. If I take the ratio of y over x for the second set of ordered pairs, I also get 6, but I do have to check the third one to make sure that that k is constant. I do get 6. So I see that k equals 6. That constant of variation is 6. So this is in fact direct variation, and I can write the variation function as y equal 6 times x, and I have my variation function. I hope this lesson made sense. Now go try the My Math Lab homework.